My dear students, in continuation of our example, again we shall discuss even and odd nature of f of x in the interval 0 to 2 pi. Refer here, the interval has been changed and related to Fourier series. Therefore, let me go for the definition once again. In the interval 0 to 2 pi, if f of x is said to be even, if f of 2x minus pi is equal to f of x, and odd if f of 2 pi minus x equal to minus f of x. What does it mean? It indicates when the given function is replaced by the function minus pi, then if it is the same, it is even. If it is minus of the given function, it is odd. Therefore, now we shall see the one property of the definite integral. Integration between 0 to 2a f of x dx equal to 2 into 0 to a f of x dx, provided f of x is even, is equal to 0 when f of x is odd. I think you might have seen this property in your PU second year. I am reconsidering the same thing. And the related Fourier coefficients are given by a0 equals to 1 upon pi between 0 to 2 pi f of x dx, an is equal to 1 upon pi between 0 to 2 pi f of x cos nx dx, and bn equal to 1 upon 2 pi f of x sin nx dx. These are the related Fourier coefficients in the interval 0 to 2 pi. Refer here. And again, when f of x is even function, what shall? As we known in the previous condition, again bn will be 0. Okay, bn equal to 0, and a0 is given by 2 upon pi by this property. It is 2 upon pi between 0 to 2 pi f of x dx, and n equals to 2 upon pi between 0 to 2 between 0 to pi. It is 2 upon pi between 0 to pi f of x dx. n is equal to 2 upon pi between 0 to pi f of x cos nx dx, and obviously bn is equal to 0. And when the case 2, f of x is an odd function, again a0 and n will be 0. a0 and n will be 0. bn is equal to 2 upon pi between 0 to pi f of x sin nx dx. Okay, these are some of the properties relating even and odd function. Let me consider one example. For f of x is given by x square in the interval 0 to pi, and minus of 2 pi minus x bracket square in pi to 2 pi. Refer here. If we combine these two, what is the interval? It will be between 0 to 2 pi. It has been bifurcated in this manner. And in the given function, you can put the question how it is possible to check whether the given function is even or odd when it has been either bifurcated or trifurcated. Let me explain the same thing. Let phi of x equal to x square. The first function is given by x square, and psi of x equal to minus of 2 pi minus x bracket square. Now phi of 2 pi minus x equal to 2 pi minus x bracket square. This has been followed from the definition of even function in the interval 0 to 2 pi. This term is equal to minus psi of x because due to the minus sign, and the given function is minus of 2 pi minus x bracket square. There is no minus sign, hence it is minus of psi of x. Phi and psi are just other notations to define the functions. Therefore, f of x is odd in the interval 0 to 2 pi. Obviously, a0 and n is equal to 0. Therefore, bn is equal to what? 2 upon pi between 0 to pi. It has been shown here, f of x sin nx dx. Again, using the Bernoulli's form of the integration, u into v1 minus u dash into v2 plus u double dash into v3. Interval is between 0 to pi. Substituting the respective values, take the care that the second term becomes 0, since sin of n pi is equal to 0, sin 0 is equal to 0. By putting the upper and lower limit for cos n pi, this term will be substituting, it is what? 2 pi upon n, and again put cos n pi is equal to minus 1 raised to n. And by adding a subtraction and so on, it will be 2 pi upon n minus 1 raised to n plus 1 plus 4 upon pi n cube minus 1 raised to n minus 1. Therefore, the Fourier coefficient is given by putting the respective bn, and a0 and n is equal to 0. Okay, the next example will be f of x equal to x in the interval 0 to pi, and x minus 2 pi in the interval pi to 2 pi. And this example has been given for the practice purpose. Just do the homework yourself. Thank you.